Welcome. We're going to graph some linear inequalities. Let's start off with basic linear inequalities as a review and a reminder about the greater than and less than and equal to as well. So we're going to do each one of these types here with different variables, but they still matter. We're going to make a basic number line. We'll say 0 is here and 3 is here. And what this one's showing is less than. So the x value, whatever it is, can be any number that is less than 3. So we do an open circle, and we do an arrow going to all the numbers that are less than. It's an open circle because 3 itself is not acceptable. If we put 3 in that, we would have 3 less than 3, which is not true. 3 is equal to 3, but it's not less than. Okay. Another way that some people will sometimes draw these kinds of graphs when they're showing it is like this. They do the open circle, which is required for this, and then they go up and over like that, showing that it's all the numbers just like this here. So it's by two ways of doing the same thing. Let's do that over here with y is less than or equal to 1. So let's say here's 0 and here's 1. I'll do it with both of these, 0 and 1. This one, because it has the little equal sign, half of the equal sign is underneath there. That means it's less than or equal to. So y is less, every number that's less than 1, but it can be 1 as well. So we can show it this way with the closed circle. That one is bigger too. So the closed circle means included. So here it's not included. And here it is included. So if I was to put the number 1 into this equation, say 1 is less than or equal to 1, that is a true statement. 1 is not less than 1, but because of the equal sign, 1 is equal to 1, and therefore it's an acceptable answer. Okay, let's do the same thing over here with this m greater than 28. So I'm going to 0 here, and that means I'll put 28 here. So there's very tiny little lots of numbers in between. That's going to be that it does not include 28, but it's all the numbers that are greater than 28. So I'll also show it this way. 0 and 28. This, oops, not filled in. And up and over. I don't care which way people do these, one or the other. Don't do both, but one or the other. And then the last one is going to be 0, and say 19 is like here, so a different scale. This one's filled in and then going out towards infinity, going forever. 0, 19. And so we'll fill this in and go up and over like this to show that one. So that's what you do when you have a variable and then it's greater than something, or greater than or equal to something, or less than or equal. But most of the time in math, we don't give you a simple one like that. We complicate it by having you do something first to get to these. So like here was this one, this one, this one, this one, all ready to graph. Well, the next ones, adding or subtracting, they're not ready. You have to change them. So we're going to do +4 and +4. So we have x less than or equal to 14. So now that we have that, we could graph it if we wanted to. This one doesn't ask us to, but at this point we could graph it. So if I wanted to graph it, I do 0, 14, closed circle because it's equal to, and then I would go down this way, or I'd go up and over that way. Either one would be acceptable, not both. But in this case, I'm just showing that off. Then on the other one here, this is the one, well, this first one, we had to add the 4 to both sides because we were, let's get, okay. No, I didn't want it to disappear. I'm going to keep fighting it until I win. Until I win it. Yeah, there's enough of that on there. And so I add both sides because that makes this 0 here, isolates the x. Over here, I'm going to have to subtract 4 in order to make it 0 and isolate the x, but I have to do that on both sides. So we get less than or equal to 10 take away 4, 6. That would be the answer to this. And it doesn't say to graph it, so I'm just simply going to add and subtract that second one and leave it there. In that case, I really want to be able to mark these in. This time they worked. Good. When you multiply and divide, well, the adding and subtracting is just like adding and subtracting, but just had an equal sign. So there's no real difference in those. But when you multiply and divide, half the time it's just like multiplying or dividing. And normal is if you had equal signs, and the other half the time it's not. So I will show you the difference here. And we're going to do two sets. We're going to do A, B, C, D, and the F, G, H. A, B, C, and D, it's almost as if you had equal signs. We're just going to do the opposite thing. So here we'll multiply by 3. That's dividing by 3, so we'll multiply by 3. And that will give us that these 3's cancel out. X is greater than 36. On this one, we'll divide both sides by 3, okay, which will cancel that out and will give us X is greater than 4. And then we can do here. Now, when you have this kind of thing, there's a couple of ways to do it. You could do it as 2 steps. First, multiply everything by 3, and then second, divide everything by 2. You can also use the reciprocal, because if you do the reciprocal, notice I'm going to do that on both sides here, 3 over 2. For the reciprocal, you end up canceling the 3's, canceling the 2's, and just X is left over. And here, 2 goes into 12 6 times, so 3 times 6 is 18. Okay. On the next one here, what was the difference? Oh, there's no difference. Oh, okay. I did this one reciprocal. On this next one, let's show the longer way, just for people who would be comfortable with that. I'm going to multiply both sides by 3. So I'm going to get those 3's canceling 2x greater than 36. I want to make that a better 3 than I'm showing here. And now here I'll divide by 2, and it will give me x greater than 18. We get the same answer, but this one is with 2 steps, which is perfectly fine if that helps somebody make sure they get it right. So 1 step, okay, using a reciprocal, or doing it in 2 steps. Notice that all of these are positives. We're multiplying or dividing with positives. That makes it almost as if there was still just equal signs, and we just keep inequality in the same setup place where it was. It's different if you multiply or divide by a negative number, and that's what we're going to look at here. So I'm going to do the same kind of thing here, where I'm going to multiply this by 3, but there's a negative number. So in this case, well, actually in this case, let's first just multiply by 3. And so what I get is negative x greater than, oh, I didn't write 3 here, so now let me write it. There, now it's written. It's greater than 36, but I have a negative there. And so what I have to do is either multiply, because that's really a negative 1. I can either multiply by a negative 1 to make it positive, or I'll divide by negative 1, because that's in keeping with the normal ways we've done these. So the 2 negative 1's there cancel out. But when you multiply or divide by a negative, you have to change the inequality sign's direction. And of course, you get a negative on the other side. That is vitally important. Okay, so write something, bottom, top, on the side, or something like that. Write something about this. When multiply or divide by a negative number, must reverse direction of the inequality sign. That is key thing to remember when you're dealing with negatives anywhere in one of these. If you add or subtract with a negative, there's no problem with that. It's only when multiplying and dividing. Now, next one. Here in this case, I see a -3, and so I'm going to divide by -3. Divide by -3. So the -3's here cancel out, the negatives and the 3's. I get x, but I have to remember then to change the direction of the inequality sign, and I get a -4. Okay. So on the next one, I'm going to do this one with the reciprocal, and the one after it, I'm going to do in the 2 steps. So here, I'm going to, maybe even 3, no, not 2. I'm going to multiply by a -3. Let's see. Let me do -3. I'm going to make this so it's very clearly -3/2 here, and a -3/2 here. Okay. So on this one, the 3's cancel, 2's cancel, and the negatives cancel. And I have x by itself, but because I'm multiplying by a negative, I have to reverse the inequality sign direction. Now here in this case, what I need to do for the next one is let's do this a little more detailed like that. Okay, that's actually -3/2 times 12/1, and 2 can go into 12 6 times. So we get a -18. Now come over here. Let's do this one, but now it's greater than or equal to. Whoops, I have to be careful down here to make sure that I don't make the box where it runs that equal sign and makes it seem as it's equal. So I changed or switched the direction of the inequality sign. On the last one here, I'm going to do this in 2 steps. I'm going to multiply by 3, and the 3's cancel at -2x greater than -36. Now, the fact that this one's negative doesn't mean anything. What matters is this negative here, because now I'm going to go ahead and I'm going to divide by the -2. I could just do the 2 and then divide by -1 later, but might as well do them both at the same time. Those cancel out, and these cancel out. But we have to change that inequality sign. We have x, but now it's less than, and 36 divided by 2 is 18. Okay. These in. So the main lesson here is that you do the normal stuff you usually do, but when you multiply or divide by a negative number, you have to change the direction of the inequality sign. Okay. Now there we are. So I guess that's the key thing. So what you've done on this one is graph them, added or subtracted them, multiply or divided them, and multiplied or divided them with negatives, and therefore changing the direction of the inequality sign. Okay. I hope that helps with these. Thanks for watching and listening.